Okay, in the previous lesson we have talked about the searching name and MRO method resolution order concept. But in our example we have given this concept like this one, CB pass, and we can print the C dot MRO like this one, and so we will have the total hierarchical information from this class. Okay, so just remember that if you have the multiple class information from some libraries or in the mechatronic engineering examples, you may utilize this function in order to find out which hierarchical body should be contained in your application. Okay, just giving the information. Okay, and so for the override and mechanisms, you can print the a dot foo in here like this one, and class B right from A the foo self, and print B foo. Okay, and so what about the CB with the pass parameters? And so if we can call the C function in here like this one, and C foo can be called in here, but which foo is called? This is the B. Okay, but if I define the A body in here, and so A foo is called, but if I define the B body, B foo is called in here. Okay, just remember that this is the order or the method resolution order mechanism on Python programming language. Okay, so what about the super function? We have given some specific examples in the class and the inheritance property, but what actually means the super function? Super function is a built-in function, but more likely it's indicating to the next keywords in Python is appropriate or consistent name for this property. And so super finds out the location of base class. But how can we do that? This property directly utilize the MRO function, method resolution order function, and also the basic syntax is the super function name. And so we have the class name in the first place. We will have this class name, for example, if the name of the class is B, and then this B should be given in here. Okay, and after that we can create some variables to manipulate its values. Okay, and after that we can reach the dot operator in here like this one, and then the function name should be given in here with this open end parenthesis or function calling operators. Okay, so in order to create our example, we can define the foo function within the class A, and so the print A foo can be given like this one, class B A the foo self, and print B foo. Okay, and class C, but in this case we will derive from the A. Okay, and so the foo self and print C foo can be given like this one, and also class D is given in here, but this class E is derived from B and C. This is the multiple inheritance or double inheritance for a one class. And we can also define the foo in here like this one, and so we can print the foo function. And what about this? This super function is what is using like this one. That foo can be called in here. Okay. Firstly, we should give the MRO method in here like this one. And so we have the main D in here, and B and C is given because this is a double inheritance in here. And so class main A is given because the B and C are derived from the base class of A. Okay, but if I run this code D, and what about if I call the d.foo function? D.foo function is in here, but we have two multiple inheritance parameter in here, B and C. Okay, and so this super calls either B or C. But if I run this code, and then B foo is calling, but C is also base class for the what? For the D. Okay. How can we correct the order of this, or how can we choose the which class foo is written or is called from this super function? And so firstly we can give the parameters of C in order to what the super C is indicated by using these terms, and we should give the self body. And so in this case we will have the A foo in here like this one, because this C, the base class of C, what? The A. Okay, this is the A. But what about the D in here like this one? And so if I run this code, and again we will have the b.foo function in here. But if I call the B in here like this one, and so this B calls to what? The class A body in here. Okay, voila, this B calls the C function, right? You can use the analogy of this code, because if we have these parameters, and then we will have the what? Another interpretation of this code. Just remember that. Okay, and so if I call C, this C is interpreted with the A function, but if we can call it the B, and then the C foo is running on this page. Okay, this is the either or the identical mechanism of the double inheritance mechanisms. Okay, and so if I call D, and in the first place we will call the B function body, and then we will have the B foo function. Okay, this is complex, but if you have the any information in here, or if you solve the examples of the Python program, and then you will have the total definition of this code. But in this lesson we will create some main examples. Okay, just like that. For the foo function, for the super function, we have the another example in here like this one, a.foo. Okay, the class B A can be derived from the what? The def foo self, and we can print the b.foo, and we can call the super function foo. Okay, because the super is a base class, and base class is indicated with the what? With the A, and so A possesses the foo function, and we can call the foo function. Okay, and so class C B can be derived in here, and the foo self, and print C foo like this one. Okay, and super function can be calling right now. Okay, and so the C can be created with the C constructor. And so what about if I calling the what? The C.foo. If I run this code, this foo is calling, but this super function calls the what? The B function, and this B function is called the super foo function, which is equal to the what? To the A foo. Okay, and so In the first place, we will see the C, after that B, after that A. Okay? And so if I run this code, and so CBA is written on the what? On the output page. Okay? Just remember that this method resolution order is important for the what? For the implementation of the inheritance class. Okay? Or inherited class. So, any question? Okay. So what about this code? Class A can be defined with this term, like this one, A foo, and B is derived from A, def foo, print foo, super foo. Okay. And so the class C also derived from A, and therefore self print C foo and super foo. Okay, and after that D, B, and C foo, and therefore self and print D foo and also super dot foo can be called in here, and if we create the dd, and d foo is calling right now. And so what's the output of this code? In the first place, we should see that the this foo within the d class is called, and d foo is written on the page. After that, the super foo is indicated with the first parameter of these terms, and so this terms is the what? The b foo. Okay. And after that, this B calls to the what? To the C function, because in the second place we have the C parameter in here, like this one, because this super foo is indicated with the what? With the class A, because the B and C are derived from the A. And so in the last case, we will see the A class parameter, which means that we have the D, B, C, and A are called on this page. Okay. In the multiple inheritance. Okay. So what about the calling init function or the constructor in class or multiple inheritance parameters? Firstly, as always we do, the class init can be defined with these parameters, and so we can print the what? The a init function, like this one. Okay, and after that b is derived from the a, and so def init can be defined with these parameters, like this one, and so the print b init can be called. But this super can be written like this one. Okay, and so this is the identical for the what? The super function and the a function, because the a is the base class for the what? For the b class. Okay, we can just write these terms like this one. Okay, and so class C is also derived from a, and so def init function body can be called like this one, and so we can change this super with the a parameters, and after that we can print the C constructor or C init like this one, and after that we should give this class D, B, C, and def init body in here like this one. But in this case we will have the two base class in here, and so B init should be called with the parameters of the self, and C init should be called with the parameters of the self, and D init can be written to warn the user like this one. And so if I run this code and create the D variable, and then we will have the error. I'm sorry. This self should be given in here like this one. Okay, And so if I run this code, the a init firstly given in here, because if we call it this one, and so def init is called for the program, and after that the b in itself is calling, and so b in itself in here like this one, and so this b in itself calls the a in itself, and so a in itself is what is written in the first place. After that this code is turned into the what, this b init function body in here like this one. Okay, and so the c is called in here like this one, and then the c calls the what, the a init function, and so this a init function calls this one, and so the third term is assigned to the what, the a init, and after that this c init is seen on the page, and in the last case we will see with the what, the print d init function body. Okay, this is the resolution order of the what, the constructor mechanism in Python programming language. Any question? Guys, these are the simple syntax, but are important syntax, because if you want to create some classes or some create projects, anything about that, and so we need to understand the syntax of the Python. Okay, and so these simple rules determines your code efficiency and professionality, or the visualization of your code depiction in the resolution order, and so these are important, and so you need to understand the underlying mechanism of the what, the interpretation of the Python. Okay, just remember that these are important concepts. Okay, so in order to clarify this constructor mechanism, we can give the another example in here like this one, the a init, and class b def init print b init, and class c a and b is derived from the what, these terms. Okay, and then the super function with the c and self can be given in here like this one with the init function body. Okay, and so we can print the what, the c init in here like this one. Okay, this is the r term in here, and after that we can create the c and c. Okay, and so if I run this code and the c is not defined in here, okay, I'm sorry, that init function body should be given in here, and so we can give these parameters in here like this one. If I run this code, the a init firstly calls and the c init firstly calls like this one, because the super c self is written on the what, on this page, and after that the c init is given in here. But what about the b and a order given in here like this one? And so the b init is firstly called and c init firstly called. Okay, it's another example to what you understand the method resolution order. Okay, so class A can be given in here, def init, and we can also print a init function body. Class B can be defined with the initialization parameter like this one, the print b init. Okay, and so the class C and B can be given def init parameters. Okay, so a init function can be called with the self parameters, b init function can be called with these parameters, and so this print c init function can be called like this one. Okay, and so this c is running at this case, so the a, b and c are called at this time, but in the previous example we have two constructor, but in this case we have the three constructor, because we can call it right now like this one, and so this builds the whole the class B parameters and the variables or the methods in this in this multiple or double inheritance case. Okay, and so this super function calls only one parameter, but if you want to create the A and B constructor or the storage area from the from the RAM, and so we need to call this function by using with the specific name of the classes. Okay, any question? Okay, if there's no question, we will continue with the new topic of the Python programming language, which we call it to the to the encapsulation. What's the meaning of the encapsulation? Do you know about it? Guys, answer me. There's no answer. Okay. So, encapsulation means that data hiding mechanism in which we can store any variable for a given class, and the other parts of code cannot see these features. Okay. For example, in C or C++ programming language, especially for the inheritance, we have the three subject area: private, protected, or the public region. But in Python programming language, we don't have such kind of mechanism. Okay. And so we can like this one. In Python there are no sections like the private, public, or protected area. And so if we have the some classes in Python, and if you want to hide the some data from the user or from the other class or inherited class, and so we can use this definition. But in Python we don't have the such kind of mechanism like this one. But there is some specific usage or utilization for the definition of the class. For example, if we want to, or if we have derived the class like this one, the sample, we can create the constructor parameter in here like this one with the self A. Okay, and so self A can be defined with the A. This one underscore terms means that the private object definition in Python programming language, but we can reach this parameter in the outside. It's a simple idiom or the utilization of the Python programming language to indicate the private objects, but outside of the class we can anyway reach these values. This is a warning for the user or for the developers. Okay, for example, def disp self, the print self A can be given in here, but we have the foo function in here like this one, self foo. If we can print the simple foo in here like this one, we may have some other mechanisms. For example, we can create the sample with the 10 values in here, and so if I run this code, and then we have no syntax error. Okay, and so we can disp to what? This value, just like this one. And so as A can also be reachable from the outside, but the standard definition is the private objects. But what about this function? foo function, if the calling the foo function is given in here like this one, and so we have the what attribute error. Sample object has no attributes as a foo function, but we can call these terms like this one, the self foo in here like this one. For example, if I run this code, this foo, this foo can be called inside of class, but the other terms or the other parameters cannot be reached this function body. Just remember that, okay? Or maybe we can be even in here like this one, 20, and so what about this parameter? B equals B, okay? And so print as B can be written like this one, and so we will have the sample object has no attribute B, but in this function body we have the what, the B in here like this one, and so this B is written on this time, and so this is also error and this is also error, okay? But if we define the double-2 underscore values, and so this double-2 underscore hides the whole data from the outside of this code, but the class possesses this code in the what in itself usage, okay? This is the encapsulation of the R Python programming language. Any question? So there's no question. We can create some polymorphism example. What is the meaning of the polymorphism? Employee can be given with what the def init function body, and so the name is given in here, and self.name is the name, okay? And so we can define the class worker, which is derived from the what, these terms like this one, and so def init function body, self name, and the week hours can be given in here, okay? And after that the self week hours can be given or initialized with the week hours, and also we can calculate the salary of our problem like this one, the return values of the what, the self dot week hours times 30 is the each time is assigned to the what, the 30 liras or the $30 for the what, for this salary. Or we can create the class manager in here like this one, the employee, and after that def init can be called, and we can give the sum prim in here like this one, and so the self prim and prim. I don't know the English words for the prim, and so I apologize for that. And so def calc salary self and return 7,000 times self prim, okay? And also we can drive the class to what, the salesperson, okay? Employee, and after that we can give the another terms in here like this one, the self name prim and self prim, and 3,000 can be given in here, okay? So these are the what, the each person or the each type of the workers in the what for a given company: salesperson, manager, worker, or employee. Every class derived from the employee, okay, right? Because every person has a name, in here. But the other class is the what is a specialized class, and which is called the polymorphism. Çok yönlülük. Okay? And so each class has a specific calculation of salary. For example, for the workers, we create the what? The week hours time 30. But for the manager, we have the standard salary plus prim times 7,000. For the salesperson, we have the standard salary plus the prim. Okay? And so we can create the what? The employees. Like this one. For example, we can define the workers Furkan 40, and we can define the managers Berkay 0.2, and we can define the salesperson Mehmet and 0.1. Okay, this is the standard definition of these forms. And so we can create the for loop in here like this one, for the employees. And so we can iterate the whole variables in here with the printing information, what the name and salary, and can give the formats of the what, the amp name and amp salary or calc salary. Okay, function. So where is the polymorphism? Polymorphism means that this amp possesses the worker, manager and salesperson, but each salesperson or manager or worker function different calc salary functions in here, like this one. This is called the polymorphism of the Python programming language. Okay, and so if I run this code, and so in each case different salary function can be called from the programs or the Python interpreter, which means that if we have this information, we can drive the whole class from the employee, but we can specialize whole the classes with what, with the specific purposes, with the same name of the function, but each function has a different purpose in here. Okay, so after that we can utilize the for in employees body in here like this one. We can calculate the salary or the total salary function, amp calc salary in here, and salary can be defined in here like this one. And so these employees possess the whole, the salesperson, manager and worker, but this employee calls a different function or different definition of the function, and so we can easily calculate the total salary function body in here like this one. This is a huge advantage of the what, the inheritance and polymorphism of the what class definition in Python programming language. Okay, and so total salary can be defined with the what, with the format salary in here, and so we can easily calculate the total dollars or the liras for the what, for given to the workers or the manager or the salesperson. Okay, this is called the polymorphism mechanism in Python programming language. Any question? Okay.